Good morning, students. This is surface chemistry chapter. This is fourth chapter. This is completely theory chapter. We will not face any numericals regarding this chapter in CBSE level. So here, first we have to know some 2 points. One is surface and another one is interface. We know that surface is top layer of substance. The top layer of substance is called surface. The next layer of the surface is called interface. That means nearly from surface to nearly 10 to the power of minus 7 centimeters distance. That part is considered as interface. So here the definition of surface chemistry means the branch of science which deals with surface or interface of the substances is called surface chemistry. Means if any science which deals with surface or interface of the substances is called surface chemistry. Before that, first we know one definition, one important definition, that is adsorption. Adsorption means it is a surface phenomenon. That means, for example, if you apply paint on the walls, that means paint attached on walls. So that is example for adsorption. One more example, if you write pen on paper, then that ink is attached on paper. So that is also example of adsorption. Similarly, one more best example, that is applying powder on our face. That is also example for adsorption. In these cases, what happened? One substance is attached on other substance, but not that substance should not go in inner side of the other substance. If you write pen on the paper, that ink is attached on paper only. That will happen only. But that ink cannot undergo into the paper. This ink is attached on surface of the paper only. If you apply powder on the face, that powder cannot go into the face. That is attached on surface of the face only. It cannot go inner side of the surface. Similarly, if you apply paint on the wall, that paint attached on the wall only. That paint cannot go into wall. So I hope you understand the definition clearly. So here the definition is the process of accumulation. Accumulation means group of particles. Accumulation of particles on the surface of the other substance. That means these particles attached on surface of the other substance. Then that process is called adsorption. It is a surface phenomenon. Here two important points is there in adsorption. One is adsorbent and one more is adsorbate. Adsorbent and adsorbate. Adsorbent means the process in which the substance on which adsorption takes place. Thus, the substance on which adsorption takes place, then that substance is considered as adsorbent. For example, if you apply paint on wall, paint is attached on wall, not wall is attached on paint. So that wall is considered as adsorbent. And one more example, if you write with pen on paper, then this ink is attached on paper. That means paper is adsorbent and ink is adsorbate. ADSORBAT, adsorbate. So adsorbent means the substance on which adsorption takes place is called adsorbent. The substance which is going to adsorb on other substance, that is called adsorbate. I repeat once again, the substance on which adsorption takes place is called adsorbate. The substance which is going to adsorb on another substance is called adsorbate. If you apply powder on face, powder is adsorbate and face is adsorbent. I hope you understand the definitions. Here some more examples are there regarding adsorption. Adsorption. First one is a charcoal is placed in a vessel. You know, charcoal is carbon. It is made up of carbon only. That contains carbon atoms only. It is a solid substance. If that solid substance is placed in a vessel that containing, suppose that vessel contains gases, then what happens after some time? The gases in the vessel undergo adsorption on the surface of the charcoal. Then no gases is present. Very few gases are present. Then automatically what happens? If amount of gas increases, automatically pressure of the gas also decreases. If amount of gas decreases, then pressure of the gas also decreases. So after putting charcoal in the vessel, what happens? Then the pressure of the gas decreases because of adsorption of gases on charcoal. That is one example for adsorption. One more example. If the same charcoal is placed in methylene blue color solution, that is in blue color, after some time the solution turns to colorless because the particles present in methylene blue color solution undergo adsorption on surface of charcoal. Then that whole solution becomes colorless because of adsorption. And one more example, silica gel. It is a blue colored substance. Sometimes it is in white color substance. Its composition is SiO2, that means silicon dioxide. When that substance is placed in moisture means air contains more amount of moisture. After some time, then that air becomes dry because of adsorption of moisture on the surface of the silica gel. This is very important point. If silica gel is placed in a moisture air, after some time the air becomes dry. Why? Because the moisture undergoes adsorption on the surface of the silica gel, then moisture air becomes dry air. So these three are examples for adsorption. Next definition is absorption. AB, there AD, that is surface phenomenon, we discussed already. AB, absorption. Absorption means, here the definition is small difference. The process of accumulation of particles in the bulk of the substance. Bulk of the substance. The process of accumulation of particles in the bulk of the substance. Here the definition is the process of accumulation of particles on the surface of the substance. That means here the particles should be attached on the surface only. Here the particles should go into inner side of the substance. Should go into inner side. Then only that process is considered as adsorption. Absorption. For example, take sponge. If you dip that sponge in water, after some time what happens? All that water undergo into sponge. No water is present on surface of the sponge. You can experience in your home. No water is present on surface of sponge. All water is present inside of the sponge when you put sponge in water. So in that case what happens? That one substance is enter into another substance. So here this is called absorption. Absorption. Next one. Next definition is sorption. Sorption means the process in which both phenomena should take place. Both phenomena means both AD and AB. That means adsorption and absorption both takes place. That is called sorption. Sorption. So for example, here one example is there. If white chalk is dipped in blue in colored solution, white chalk is dipped in blue colored solution. After some time what happens? The blue colored particles get adsorbed on the surface of the chalk. That means the chalk becomes blue color. White chalk becomes blue color. And the water moves into the chalk from the solution. That means that from the blue colored solution, the water enter into the chalk. and that means absorption occurs. That means here both two phenomena should be taken. One is adsorption, one more is absorption. If you put white chalk in blue ink colored solution, then after some time that white chalk piece becomes blue color, and the water which is present in blue color solution enter into chalk. That means both phenomenon takes place. This is the example for sorption. So sorption is what? Both adsorption and absorption. That is called sorption. During adsorption, delta H, delta S and delta G, these are negative values. We should discuss why these are having negative values during adsorption. Here one important point is there, but for that first we have to know enthalpy. Enthalpy means it is represented by H. Change in enthalpy is represented by delta H. We discussed all these points in class 11 thermodynamics chapter. That is nothing but one of the energy term. And enthalpy is nothing but one of the energy term. What happens during adsorption? All molecules of one substance comes close to another substance because of attractions. Then if attractions are there, then what happens? Those molecules loses energy. After adsorption, those molecules loses energy. If energy is liberated in any process, then that process is considered as what? Exothermic process. So in exothermic process, delta H is negative. So that is the reason behind delta H is equal to negative. Next one, why delta S is negative? Delta S is what? Change in entropy. Entropy, we know entropy is what? Measure of randomness of system is called entropy. In solid state, liquid state, gas state, in which case randomness is more in gas state, because in gas state the particles are in free state. Because in gas state the attractions between particles is very less. If attractions are very less, they move readily from one place to another place. So delta S value is positive in that case. But here what happens during adsorption? Particles of one substance comes close to another substance. That means attachment takes place. After that means the particles will become a rest. The particles will become a rest. If the particles will become a rest, that means there is no chance to move. That means its randomness decreases. That is why delta S value is negative. Okay, if delta S and delta S is negative, then what about why delta G is negative? We know the formula. Delta G equal to what? Delta H minus T delta S. Delta H minus T delta S. Already delta H value negative, delta S also negative. So finally delta G also will become negative. So point is what? Adsorption is a spontaneous process, because delta G is negative, that is called spontaneous process. Here one important point is there, that is after some time during adsorption the negative value of delta H decreases. Negative value, suppose initially delta H is equal to minus 100, then the negative value of delta H decreases, means after some time what happens? Delta H becomes minus 90 or minus 80. That is the meaning of negative value of decrease of negative value, and it becomes equal to T delta S value after some time. That means delta H and T delta S values equal at one stage. Then if these two values becomes equal, then automatically delta G value becomes equal to 0. This is the formula, since delta H equal to delta H minus. If these two become equal, then delta G become 0. Therefore, we can say that adsorption is in equilibrium. That means that if delta G is equal to 0, adsorption is in equilibrium. Formation of adsorption is spontaneous, that is okay, because delta G is negative. But after some time, adsorption is in equilibrium, because these two values becomes equal after some time. That can be explained experimentally. So automatically delta G is in equilibrium. So this is about introduction of surface chemistry. Next topic is very important thing, that is types of adsorption. types of adsorption. Based on the attraction forces between adsorbate, I told you what is adsorbate and what is adsorbent. Based on the attraction forces between adsorbate and adsorbent, adsorption is classified into two types. One is physical adsorption, that is also called physisorption, and another one is chemical adsorption, that is also called chemisorption. Physical adsorption and chemical adsorption, these are the types of adsorption. This is very important topic. Now we discuss about types of adsorption. Now types of adsorption, that is physical adsorption and chemical adsorption. In case of physical adsorption, if van der Waals forces present between adsorbate and adsorbent, then that is called physical adsorption. Van der Waals forces means very weak forces. If chemical forces are present between adsorbate and adsorbent, that is called chemical adsorption. Chemical forces means either ionic forces, covalent forces, those are present between adsorbate and adsorbent, that is called chemical adsorption. For example, in this case, if you apply powder on face, what happens after some time? That powder undercoat disappears because weak forces present between powder and face. Here, if you pass hydrogen gas on palladium metal, then adsorption takes place. After that, we cannot remove hydrogen gas easily from palladium metal because strong forces present between hydrogen and palladium metal. So because of weak van der Waals forces, it is weak. Because of chemical forces, it is strong. Next, it is not specific because it is weak, but it is highly specific because it is strong. Next, it is multi-layered, but it is unilayered. That means, this is a very important point. Multi-layered means, for example, before applying powder on our face, we can apply some cream. After that, we can apply powder. So in that example, two adsorbates are present on one surface. One is cream and powder. That means two layers are present. That is called multi-layered. That means if more than one layer is present on substance, that is called multi-layered. Or more than one adsorption takes place, that is called multi-layered. Unilayered means after adsorption takes place, then there is no chance of further adsorption, that is called unilayered. For example, after passing hydrogen gas, then that means adsorption takes place by palladium metal. After that, if you pass one more gas on palladium metal, then that palladium metal cannot adsorb that gas because already strong adsorption takes place between that metal and gas. That is why this is called unilayered. Next one. Here the enthalpy of adsorption is low. Enthalpy. Why enthalpy of adsorption is low? Because it is weak. Because of weak van der Waals forces, they release very less energy. But here, because of strong forces, they release more energy. That is why enthalpy of adsorption is high. Enthalpy nothing but delta H. Here delta H is less, here delta H is very high. Next one, if pressure increases, then adsorption also increases and reaches maximum. After some time remains constant. That means if you apply pressure initially, physical adsorption increases. But again, if you apply more pressure, then the adsorption remains constant. That means then there is no chance of further adsorption. There is no chance of strong adsorption. Initially adsorption increases, but after some time adsorption remains constant. But in case of chemical adsorption, pressure has no effect. In case of chemical adsorption. This is a very important point. Next one. This is also important thing. If temperature increases, physical adsorption decreases because here weak forces are present. If you apply temperature, then those weak forces will be broken, and then automatically physical adsorption decreases. But here, if temperature increases, initially chemical adsorption also increases initially, and reaches maximum. And if you increase more temperature again, then what happens, those chemical forces are also will become broken because of high temperature. Then what happens again, chemical adsorption decreases. This is important thing. Initially in this case, if temperature increases, chemical adsorption also increases, but if you apply more temperature, then those forces will be broken because of high temperature, then automatically chemical adsorption decreases. So these are what types of physical and chemical adsorption. Especially these 3 points are very important: multi-layered, unilayered, pressure, temperature. Here pressure has no effect in this case, chemical adsorption. Here temperature increases, physical adsorption decreases. These 2 points are important. These 3 are very important regarding types of adsorption. Next topic is factors influence adsorption of gases on solids. So this is very simple topic. Here 3 factors are there which influence adsorption of gas on solids. First one, nature of gas. Before that, we know 2 points. One is liquefiable gases, non-liquefiable gases. One more point, critical temperature. In class 11 we discussed already critical temperature. That means the temperature below which the gas can be converted into liquid by applying pressure. That is called critical temperature definition. One more definition is the temperature above which the gas cannot be converted into liquid by applying pressure. That is called critical temperature. Here important thing is, if critical temperature of the gas increases, then that gas is easily converted into liquid. Next, liquefiable gases means the gas which has tendency to convert it into liquid easily is called liquefiable gas. Non-liquefiable gas means the gas which has not tendency, which has not that much tendency to convert it into liquid. That is called non-liquefiable gas. So the gases which have more critical temperature, then those gases are having liquefiable gases. Liquefiable gas means the gas which is readily converted into liquid. That is called liquefiable gases. Which is not readily converted into liquid is called non-liquefiable gases. So which gases are considered as liquefiable gases? The gas which is having high critical temperature is called liquefiable gases. Here the point is what? How nature of gas affect adsorption of gases on solids. If easily liquefiable gases are there, then they undergo adsorption easily. That means they easily undergo attach on surface of the other substance. They will undergo adsorption easily. For that, they should have high critical temperature. Then automatically adsorption of gas on solids increases. Next one, surface area of adsorbent. That means if surface area increases, adsorption also increases. How? Suppose here I take 2 substances. One substance surface area like this, one substance surface area like this. In which case is there any chance of more adsorption? In this case, there is no chance of more adsorption, because here surface area increases, automatically adsorption also increases. That's all. Next, pressure of the gas. At constant temperature, that means temperature is constant. If pressure of the gas increases, then adsorption of gas also increases. That means at constant temperature, if you apply more pressure, then the pressure of the gas increases, then adsorption also increases. So these are the factors which influence adsorption of gases on solids. Next topic, Freundlich's adsorption isotherm. Freundlich derived this one. This is totally related to physical adsorption, not for chemical adsorption. Here the one graph is there. Here that graph is drawn between x by m and p. Before that, we have to know what is x and what is m and what is p, where x is amount of gas adsorbed and m is mass of adsorbent. X is amount of gas adsorbed on adsorbent. then x by m is what? Extent of adsorption. So here the graph is drawn between extent of adsorption and P. If you see the graph, here three relations are there. This is the relation at low pressure. This is the relation at a medium pressure. See, from left to right, pressure value increases. This is the relation at a high pressure. What is the point here? See, along with x by m, P increases. This increases. But here it is constant. This indicates three statements. At low pressure, extent of adsorption is very high. That is the first point. At medium pressure, extent of adsorption is not high, not low. At high pressure, extent of adsorption is constant. So three relations. Here x by m is directly proportional to P. Here x by m is directly proportional to P power 1 by n. Here x by m is proportional to P power 0. Why here we put P power 0? Because P power 0 nothing but 1. That means at high pressure, this is high pressure. Here extent of adsorption is independent on pressure. That means if you apply more pressure, then adsorption remains constant. I told you already in types of adsorption. As pressure increases, adsorption also increases. But after some time, it remains constant. That means when we apply high pressure, extent of adsorption is constant. So at low pressure, extent of adsorption is high. So the three relations is, at low pressure x by m is proportional to P. At high pressure x by m is proportional to P power 0. Here P power 0. Which value is here? P is more compared to P power 0. Because that is at low pressure this value is more. Here at medium pressure, I told you that is not high, not low. That is why we should mention here 1 by n, P power 1 by n, where 1 by n is lies between 0 to 1. See here 0, here 1 by n, here 1. So 1 by n value is lies between 0 to 1. So if you consider that, if you take this expression x by m is equal to, if you remove the proportional, then we get one constant k into P power 1 by n. Then if you apply logarithm, then we get one relation, that is log x by m equal to 1 by n log P plus log k. This relation is in the form of y equal to mx plus c. Then if you draw the graph between log x by m versus log P, then this will be slope is 1 by n. Then we get the graph like this. This is intercept, slope is equal to 1 by n. Here one more point is there regarding this one. See, if you draw the graph between x by m versus P at a different temperatures T1, T2, T3, then this will be the final relation between temperatures T1 greater than T2 greater than T3. See, here T1, this is T2, this is T3. I told you already, as temperature increases, this graph is totally related to physical adsorption. As temperature increases, physical adsorption decreases. So here T1 is less compared to T2, T2 is less compared to T3. So T1 value is more than T2 and T2 is more than T3. Next topic, applications of adsorption. First application, it is used in production of high vacuum. High vacuum means in that one nothing is there. If you put a charcoal or anything, then that charcoal or other substance adsorb gases. Then if there is no gas, nothing is there, then that will be considered as what? Vacuum. So sometimes we want high vacuum to refine metals from their impurities. So for that purpose we should apply this phenomenon, that is adsorption. Next one, it is used to separate inert gases. Next one, it is used in chromatography experiment. It is used in froth production process. Actually this process present in metallurgy chapter, extraction of metals, but that is not there in this year. That is removed recently from CBSE syllabus. And last one, it is used to control humidity. How humidity is controlled? Because if you put silica gel in moisture, then what happens? That moisture is absorbed by silica gel, then automatically humidity can be controlled. So these are the applications of adsorption. This is all about adsorption. Next topic is colloidal solution. Before that we just know two other solutions, that is true solution and suspension. Solutions are classified into three types based on size of the solute particle. If the size of the solute particle is less than 1 millimicron, 1 millimicron value is 10 to the power of minus 7 centimeters or 10 to the power of minus 9 meters. If the size of the particle is less than 10 to the power of minus 7 centimeters or 10 to the power of minus 9 meters, then that solution is called true solution. But if the size of the solute is lies between 1 millimicron and 1 micron, then that solution is called colloidal solution. 1 micron value is 10 to the power of minus 4 centimeters, 10 to the power of minus 6 meters. Here this colloidal solution is also called sol. Simply it is called sols. If the size of the particle is more than 1 micron, then that solution is called suspension. So these are the classifications of solutions based on size of the solute. So colloidal solution definition is, if the size of the particle is in the range between 1 millimicron to 1 micron, then that solution is considered as colloidal solution. Simply it is called sol. Just like solute and solvent present in solution, here the components present in colloidal solution is called dP and dm. dP means dispersed phase, that means lesser amount, just like solute. And dm means dispersion medium, that means major amount, just like solvent. So the components present in colloidal solution is called dP and dm, that means dispersed phase and dispersion medium. Now the definition of dispersed phase is the lesser part of the colloidal solution, just like solute, is called dispersed phase, and the major part of the colloidal solution is called dispersion medium. Next, here one important thing is that all colloidal solutions are heterogeneous system. All solutions are homogeneous, but all colloidal solutions are heterogeneous system. Next, based on physical state of dP and dm, the colloidal solutions are classified into 8 types. Based on physical states of dP and dm, sols are classified into 8 types. They are: first one, solid inside solid, that means both are solids, both means dP dm. This is called solid in solid type of colloidal solution. For example, gemstones, colored glasses. Gemstones means in rings we wear some gold rings. In that case, in some cases yellow color gold rings, red color gold rings, the green color gold rings are there, green color stones are there. So that stone contains two solid substances. Those are called gemstones. And one more example, colored glasses. You know, colored glasses generally we use it for drinking purpose. So those are the example for solid in solid type. Next one is dP solid, dm liquid. So this is comes under solid in liquid, not liquid in solid, because dm is more. So that is why we have to call it as solid in liquid. For that example is blood paints. Blood contains albuminides. Those albuminides present in solid state. Those are in lesser amount, but rest of the part is water. That is more amount. So blood is a colloidal solution which is solid in liquid type of colloidal solution. Next, here solid dP, gas dm. That means solid in gas type. For example, smoke, dust. Smoke contains carbon particles which are present in air. Those are in lesser amount. That is why those are considered as dP. More amount is air. That is considered as dm. So similarly, dust also. This comes under solid in gases type. Next one, liquid in solid. Because liquid is less, solid is more. That is why we have to call it as liquid in solid, not solid in liquid. For this example, cheese, jellies. Cheese contains less amount of liquid but more amount of solid. Next one, liquid. Both are liquids. Liquid in liquid type. For example, milk. Milk contains fat, liquid fat and water. Both are present in liquid state. So that is liquid in liquid type. Next, here dP liquid, dm gas. That is liquid in gas type. For example, smoke, cloud. The cloud contains liquid droplets and more amount of air. Less amount of liquid droplets and more amount of air. That is why this comes under liquid in gas type of colloidal solution. And next one, dP gas, dm solid. That means gas in solid, not solid in gas. For this example is pumice stone. Pumice stone means generally we use it for bathing purpose. That stone contains small holes. In that holes, air is trapped. That means more amount of gas is there. The rest of the part is solid. That is why it comes under gas in solid type. And next one, gas in liquid, because DP is gas and DM is liquid. Gas in liquid, for that example, froth, foam. That froth contains more amount of liquid and less amount of gas. So these are the classification. These are the 8 types. These are the classification of colloidal solution based on physical state. Here gas in gas colloidal solution does not exist, because when gas will mix with another gas, that will be considered as homogeneous mixture, but all colloids are heterogeneous mixtures. That is why gas in gas colloidal solution does not exist. Next, one more important thing here, if DM is gas, then it is called aerosol. Sol means colloidal solution, aerosol means air means gas. If DM is water, then it is called hydrosol. If DM is what alcohol, that is called alkosol. If DM is benzene, then it is called benzenesol. So this is about introduction regarding colloidal solution. Then the rest of the topics we will discuss in next video.